Hello, it's Mr. Payton and making a little extra video to help you guys with compare rational numbers. Here I am looking at the compare rational numbers lesson. I thought what I could do for you is work out some of these on your own questions in this lesson. So I'm going to go to the on your own section for compare rational numbers. I'm not going to work out the actual quiz questions. So yeah, check this out. So we had to do a little floating. Drag -4.5 and -4 3/4 onto the number line. So I want to look at -4 and I'm going further to the left. -4.5 is going to be between -4 and -5. Then -4 3/4, it will be closer to 5, right? -4 3/4 is smaller than -4.5. It's closer to 5. Think about -4 4/4, that would be 5 exactly. So that's where those two belong. Trying to make this the appropriate size. Okay, let's go to the next one. -1.5 and -1 3/4. Here's our number line. Let's find -1. -1.5. Am I going to go up here? Nope. But it's -1.5. Nope. We're going to the left. You got to remember the farther to the left, the smaller the number. Without the actual negative signs, it looks like a bigger number. 2 is bigger than 3, 3 is bigger than 2, but when they're negative, they're smaller. -2 is smaller than -1. And -1.5 is going to lie right in between -1 and -2. -1 1/4 is just going to be one bunny hop on your way. You see how there's 4 tick marks on this one? That would be -1 1/4, -1 2/4, which is the same as -1.5, -1 3/4, and then -1 4/4, or -2. All right, correct. Let's go to another one. Greater than, less than. Okay, for this one, what I would like to do is look at it on here. If you're having trouble comparing any two fractions, one of the best things to do is turn them into get them to have a common denominator. Like if you look at the denominators 2 and 8, 2, you could turn 2 into 8. And then you don't have to change 8 at all. If you look at their multiples, they have a least common multiple of 8. 2 times 4 is 8. So if I take that 1/2 fraction, I multiply it by 4 over 4, I get 4/8. Now I can rewrite this whole thing. I get -9 and 1/2. Is that greater than or less than? I'm sorry, I meant to write 4/8. -9 and 4/8 instead of 1/2. -9 and 7/8. All right, it still might be a little hard to look at until you put it on a number line. Let's make a little number line here. I'm going to have like -9 right here, -8's up here, -10's right here. So I have my denominator is 8s. So let me try just chopping this up into 8s. 1, 2, 3, 4. Oh, I meant to do a different color. But here, if that's going to be 4/8. 1, 2, 3, 4/8. 5/8, 6/8, 7/8, and then 8/8. Okay, so -9 and 4/8. I'm going to start at -9 and go over 4/8. 1, 2, 3, 4. That's where -9 and 4/8 is going to be. It's the same as -9.5. And then if we look at -9 and 7/8, well, I'm going to go 1, 2, 3, 4, 5, 6, 7. It's almost at -10. So it's farther to the left on the number line, so it's smaller. This is -9 and 7/8 is smaller. So the way this is set up, you'd want to use the greater than sign. -9 and 4/8 or -9.5 is greater than -9 and 7/8. So you would want greater than symbol here. And it's correct. And you can read their explanation as well, pretty much what I just said. Drag the rational numbers in order from least to greatest. Oh, they're all negative. So what do we have? 5.2, 4.5, negative. Let's see, I think -5.5 is the smallest. Then -5.2, then -4.7, then -4.5. Let's look at these on a number line. You might want to put these on a number line on your own. If I have a number line right here, let's say 0 is way off to the right. I got -4 here, -5, -6 down here. -5, that's a little bit off. It's like, let's make -6 a little bit further down. So -5.5 is going to be halfway between -5 and -6. -5.2, about right here. -4.7, remember you're counting from the right. Like if you're at -4, 0.7 would be 7/10 of the way down. There's 5/10, it'd be about right here. -4.5 is -4.5, be about right here. So in order from least to greatest, -5.5, -5.2, -4.7, -4.5. Okie dokie. The bank compared 3 customers' balances. The balances are shown on the table. Drag the letters representing the customers to order their balances from least to greatest. Okay, again, the smallest to largest. So the smallest number I see here is -265. -225 is a little bit larger. It's a little bit closer to 0 to the right. -2.65 is the smallest. So we want least to greatest. So C would be the first thing here. And then -2.25, so B, then the smallest balance. Oh, wait a minute. I'm sorry. This one's more confusing than it looks, because when you're talking about balances, it's how much money is in the bank, okay? If you have a negative balance, that means you have, wait, no, I think this is what they're looking for. No, that's right. Negative mind. Never mind. All right, let's move on. Nope. Up. Where am I here? Not this page. Not this page. What happened to it? I lost it. Hold on a minute. All right, I had closed it and I had to reopen it, so I'm back. Now we're doing this one. During a science experiment, the velocity of ball A was -12 3/8 miles per hour. The velocity of ball B was -12 5/8 miles per hour. Compare the rational numbers and complete the comparison statement. So we're looking at greater than or less than or equal between these two numbers. But this one, I don't even really need to do anything. Look, -12 3/8 and -12 5/8, they have the same denominator. Well, it still would help if we put it on a number line. As long as you're correctly making these number lines, you guys will get these. So we're between -12 and -13 here. And our fraction is in eighths. So let's chop this up into eighths. 1, 2, oh, no, it's further apart. 1, 2, 3, 4, 5, 6, 7, 8. So it should be 8 bunny hops to get from one number to the other. 1, 2, 3, 4, 5, 6, 7, 8. Starting at -12. If I count, remember, I'm counting to the left. If I want to do -12 and 5/8, I'm going 1, 2, 3, 4, 5. Right there. -12, 5/8. If I want to do -12 and 3/8, I'm just going boing, boing, 3 jumps. -12, 3/8. So that one is right there. 5/8 is right there. Farther to the left, smaller. So -12 and 3/8 would be slightly larger. The one on the right is slightly larger than -12 and 5/8. Remember, the farther to the left you go, the smaller you get on a number line. -100 is smaller than both these numbers. So we want a greater than symbol. because we're saying negative 12 and 3/8 is greater than negative 12 and 5/8. All right, so I'll just put that in there. And the computer says we're right. Okay. All right, ordering temperature from drag the days to order their lowest temperature, their low temperatures from least to greatest. So smallest to largest. When was it the coldest? Negative 15 is the smallest number I see here. Wednesday was the coldest day. Negative 14.2 was pretty cold, but not quite as cold as negative 15.1. So that's Monday, and then Tuesday would be the warmest day. Their low temperatures in order from least to greatest, I think would be that. Okay. This one's very similar to the last one we did. Let's just narrow it down to the inequality statement here. And look, the denominators are the same. Negative 2 and 7/8, and then negative 3 and 7/8. But so negative 3, I could see here, that's going to be smaller than negative 2. We're not even like in between the same two integers here. If you do a number line, negative 2, negative 3, down here is going to be like negative 4. Negative 2 and 7/8 is going to lie about right there. Negative 2 and 7/8. So if we chop this up into eighths, 1, 2, 3, 4, 5, 6, 7/8. And then negative 3 and 7/8, it's going to be like in a similar position, but over down close to negative 4. So negative 2 and 7/8 will be bigger. It's a larger number. It's more to the right. It's more to the right than the other number. So it is larger. Okay. So that should be greater than. Checks out. Let's see, where am I? I want to keep this video under 15 minutes. We're at 12 minutes now. Let me see. Now, these ones confuse a lot of people. We didn't get a chance to do these in the Class Connect. On Monday, it was negative 5 degrees. On Tuesday, it was negative 6 degrees. It was blank on Monday than it was on Tuesday because, okay, what are they saying here? It was colder on Monday or it was warmer on Monday compared to Tuesday. Well, on Monday, it was negative 5. On Tuesday, it was negative 6. Negative 5 is a little closer to 0, a little further to the right on the number line than negative 6. It's still pretty cold, but on Monday, it's a little bit warmer than on Tuesday. Tuesday, it goes down, the temperature goes down a little bit more, down to negative 6. And so why is that? Because negative 5 is greater than negative 6. Okay. Let's look at this one. Runner A. Well, you know what? I tell you what. For the last question, here, I'm going to pull something else up. Okay, for the last question, I'm going to look at this one that we never got to in the Class Connect, but it's from the slides, and you can see the answer laid out for you in the Class Connect slides. If we're trying to place these numbers in order from least to greatest, you know, you have some options. You could try to turn them all into decimals. You could try to turn them all into fractions. Here we have one decimal. With questions like this, I prefer to just turn them all into decimals because I can't really wrap my head around some of these fractions. Like I could tell 5.36 makes better sense to me than a lot of these other numbers. I think of money, $5.36. But if you could turn that 27 over 5, if you just do 27 divided by 5, 5 fits into 20, 5, 10, 15, 20, 25. Fits in there 5 times. 5 times 5 is 25. Get a remainder of 2. Now, instead of writing this as 5 2/5, let's tack a 0 on here and get the decimal answer. How many times 5 fit into 20? Fits in there 4 times. So that is the same as 5.4, which is a little bit bigger than 5.36. For 5 3/5 here, when I see a number that I could turn into 10, I take a shortcut. 5 3/5. I could turn this straight into a decimal by getting that 5 on the bottom to be a 10. If I just use a copycat fraction here, 2 over 2, I can turn that into 5 6/10. 6/10 literally is this as a decimal. 6. Oh, hold on. I want to write my 5. It's going to be 5.6. It's just like 61/100, 6/10. That's a little shortcut. When you have a denominator of 10, it's very easy to turn that into a decimal. That's the tenths place. It'll be 5.6. For the next one, I mean, easy once you get the hang of it. It may not be easy at first, but like you got to look with decimals. Look out for. You could turn any decimal into a fraction. Here, I'll do another example after this to kind of show you guys what I'm talking about. But 33 over 6, I'm just going to straight up divide this. What's 33 divided by 6? Well, let's see. 6, 12, 18, 24, 30. 6 times 5 is 30. Get a remainder of 3. Let's take it out to the decimal. Add a 0. How many times 6 fit into 30? 5 times. 5 times 6 is 30, so we get 5.5. But you see, like, or looking at it as a fraction, I get 5 with the remainder of 3 out of 6. 3 out of 6 is the same as 1 out of 2, or 5 out of 10. So 5.5 is the same as saying 5 and 5/10. 5 and 5 over 10. Let's just write 5.5 here. So this one we got 5.6. So you see, if we turn them all into decimals, like now I could order them a little bit better. I could see 5.36 is going to be the smallest. Then what? 5.4 is a little bit bigger. $5.40 is a little bit bigger than $5.36. $5.50, a little bit bigger than that. $5.60, a little bit bigger than that. So that's in these lesson slides. Here I'm laying them out on a number line too. But it should be the same numbers. 5.36, which is right here, the lowest number. It would be like right here on the number line. It didn't really make the dash on that. Close to there. The next number, 27 over 4, which I turned into 5.4 right there. 27 over 4, the next biggest number, 5.4. The next number, 33 over 6, which we turned into 5.5 right here. Right here. And then 5 3/5, which we turned into 5.6, $5.60, the biggest number in our list. Okay, so that's in the slides too. But like what I was talking about with decimals, a lot of sixth grade students I find struggle with this. It's once you get the hang of it, it becomes second nature. Like any decimal you could turn into a fraction, like an improper fraction usually. It depends on how many places you're going out. For example, 1.5. Well, that's 1.5. We should recognize that as 1.5. But if you directly translate it into a fraction, that is 1 5/10. Okay, that 5 is in the tenths place. The tenths place. The tenths place. So that's 1 5/10. 1 5/10. So you could turn it into a mixed number fraction like that, but you'll have to reduce it. If you really want to look at it as a fraction, you're always going to have to reduce it, or usually going to have to reduce it. 1 5/10, if you wanted to reduce that to 1.5, you would then have to like shave off or divide out a copycat fraction here. Divide out a 5 over 5 to make it 1 1/2. But another example, any decimal, let's just do a random one, 6.29. That's 6, and now we're in the hundredths place. We're out to the 100ths. Trying to change my color. 100ths place. So that's going to be 6 29 hundredths. How about just 0.54? Well, there's not going to be, it's just going to be fraction and not a mixed number, but that's into the hundredths place. So 54 hundredths. How about 96.875? Now we're on to the thousandths place, 3 digits out. So your denominator for the fraction is going to be 1,000. So this is just going to be 96 and 870, whoops, 75 thousandths. And you can definitely reduce that. So the only reason I'm showing you this is because when you're looking at like these lists of numbers, you want to be able, if you can go back and forth between fraction version and decimal version, like this, our exit ticket, one of our exit tickets today, or this one, which I think might even be from a quiz. You're given these numbers in a bunch of different formats, and you want to be able to turn a decimal into a fraction if you want to, or turn a fraction into a decimal. It'll really help you put things together. It's going to help you be more successful throughout middle school and into high school as well. If you could go back and forth between fractions and decimals and just be able to play around with the number and write it as an equivalent number. And this is sort of, you could probably tell this is like the thing that I sort of have fun with in math. Like how many possible ways can we write 0.5? Well, that's 5/10, but that's also 1/2. I could take that and make it look a little bit different with a copycat fraction. What if I multiply the top and bottom by 10 over 10? I'm multiplying it by 1, so I'm not changing its value. I could turn that into 10/20ths if I wanted to. You could write there's an infinite number of ways to write 1/2. There's not really a lot of decimal ways to write it. The only other decimals you can write would be like by tacking on zeros for that. But with fractions, you can write it an infinite number of ways. So hopefully this video helps you with today's lesson. And get back to me, email or call if you have any questions. All right. Thank you and good luck.